Hello, everybody. So, in our last lesson we found out that you can get a static charge on an object, meaning a charge that's not moving extra electrons or maybe a lack of electrons, just by rubbing two objects together. Electrons are in the outside of an atom, so it's easy to move them uh, between atoms, right? So it's the electrons that are moving. So we went and we looked at this little simulation the other day, right, where we took this balloon and we rubbed it on the sweater, and some of the electrons moved from the sweater onto the balloon as it was rubbing, and then we got a negatively charged balloon and a positively charged sweater. Now, I mean, if you have a balloon, you can actually try this experiment at home if you want. You can try it with the wall. I think I did this one in class quickly, or you rub the balloon and build up a charge. Maybe you could rub it on your hair and build up a charge, and then you have, a negative balloon and a neutral wall, and those things will attract, right? Remember, different charges attract. Negative balloon and neutral wall would attract. And you could probably stick it on the wall and it would stay there for a while. Really, the question that we're answering in today's lesson is when we rub the materials together, so for example, this balloon and this sweater, how do we know which directions the electrons will go? In this case, the electrons moved onto the balloon and they left the sweater, but why did that happen? Why didn't it go the other way around? Why didn't the electrons build up on the sweater and be taken away from the balloon? And what we can do is we can use something called the electrostatic series in order to describe that and in order to predict before it happens. That's what we'll look at today. So this is really the question we're answering. When the balloon and cloth were rubbed together, electrons moved between them. Which direction? Did the balloon or the cloth get the extra electrons? Well, we can see that it was the balloon, but how could we have guessed ahead of time? All right, so that's where we use the electrostatic series. So it is really just a list of substances or materials, and it shows how strongly those materials hold on to the electrons. And that really comes down to just the structure, the shape of that particular atom. So the atom of rubber in the balloon and the atom of wool in the sweater. How well do those different atoms hold on to their electrons? How well do those substances hold on to their electrons? If one of them holds on to electrons better than the other, it's the one that's going to take the electrons. So before doing an experiment, we can use it to determine which substances will get the electrons and get the negative charge, and which ones will lose the electrons and get the positive charge. And just as a reminder from last lesson, right? If the object is getting electrons, it has more negative, so it's the negative object. And if the object is losing electrons, it's losing negatives, it will become positive overall. All right, so let's try some examples out here. So, what is the electrostatic series? It's just this list right here. And this is a fairly short list. You can go and look up bigger ones. There's ones that have hundreds of different materials in them. This is just kind of a straightforward one with some common materials. So it's really just a list, and it's put in order. And in this case, this particular list, it has the objects that have the weakest hold on their electrons at the top. So in this case, out of these materials, acetate, it holds onto electrons the weakest. It does not hold onto them very well. So it's really easy to take electrons away from acetate. Now, as we move down the list, the things at the bottom of the list, these ones are the ones that hold onto electrons the best. So it's hard to pull the electrons away. So for example, platinum or gold, they're really good at holding their electrons. So all we do is we just look at the location of the two materials that we're rubbing together. The the material that's closer to the top has a weak hold, so it's going to lose the electrons. And the material that's closer to the bottom, it has a stronger hold, meaning it's going to grab the other material's electrons, and it's going to become negative. So it really comes down to just finding the two materials you're rubbing, looking at which one is near the top, losing the electrons, becoming positive, and which one is closer to the bottom, gain the electrons and become negative. Let's do some examples here. First example says, let's say you had silk and an ebonite rod, and you rubbed those two things together. This is a really common demo or experiment we do. So silk and ebonite. First thing we do is we just go and look those two things up on our list. So here I have silk is right here on my list, and ebonite is right there on my list. And I like to kind of circle them just to keep track of them as I go here. Okay, silk is closer to the top than ebonite. So that means silk has a weak hold. It's going to lose its electrons. It's easy to steal the electrons from the silk. Okay. So silk loses the electrons because it's weak at holding them. And that means that if it lost negatives, it becomes a positively charged object. So I would get silk being positive. Ebonite, that one is closer to the bottom than silk. So closer to the bottom means it can hold on strongly to electrons. So that means it's going to grab the electrons from silk and hold on to them. And if it has extra electrons, it will become negative. Ebonite gains electrons and becomes negative. All right, so at this point, you might want to just pause the video and see if you can try the next two examples out. And then we can check our answers together here. All right, so let's go through the next two examples here and check what you guys got. So first thing is figuring out where the materials are. So we have glass, which is right there, and we have plastic. Plastic right down here. Polyethylene is another word for plastic. Okay, so we have our glass, our plastic. So you got to think about maybe like a sheet of plastic that you're rubbing on a glass rod or something like that. Okay, in this case, glass is closer to the top. That means it has a weak hold. It will lose the electrons. If it loses them, it becomes positive. Glass loses electrons and becomes positive. The plastic or polyethylene, plastic is closer to the bottom. It has a stronger hold on electrons. It's going to grab the electrons and hold on to them. More electrons means a negative charge. Plastic gains electrons and becomes negative. Now another point is that electrons they're never created or destroyed here. All they're doing is they're just being transferred from one object to the other. However many electrons we started with, we still have the same amount at the end. It's just that some of them got moved onto the plastic in this case. A lot of the time in these diagrams, we're only showing like 3 or 4 or 8 electrons moving. The reality is it's millions and millions of electrons, right? A single electron is extremely tiny. It has an extremely tiny charge. So when we're rubbing it, it really is millions of electrons that are moving. All right, last example. I'll move those off. First thing we do is we find our substances. So now I'm dealing with plastic and fur. Maybe I have a plastic rod and I rub it with a piece of fur. Okay, once again, find our substances. There's my plastic, my polyethylene. And then I've got my fur up here. All right, so I circle those two objects. Okay, let's see here. Plastic is, out of the two, plastic is closer to the bottom. So plastic is going to have a strong hold. It's going to grab the electrons. It will get extra electrons. So it must be negative. So plastic gains electrons and becomes negative. Fur is closer to the top. Closer to the top means a weak hold. It loses electrons. Fur will lose the electrons and become positive. All right. Now we can kind of go back to this first question that we asked, right? Our first question was with the demo, right? What happens with the balloon and the cloth, or the balloon and the sweater, right? Well, let's say we hadn't done that experiment. We could still predict it ahead of time. So if we were saying, okay, the balloon and the sweater, I think it's a wool sweater in that demo. Right, so if you have a balloon and a wool sweater, what would happen? Let's say we hadn't done the experiment. Well, we would go through and we would find wool and rubber, right? Wool for the sweater, rubber for the balloon. So there's my wool, and here's my rubber for the balloon. Okay, so I'm rubbing two materials. I have a wool sweater and a rubber balloon. Okay, let's see what would happen. Wool would lose the electrons and become positive. Rubber balloon would gain the electrons and become negative. Okay, so if I rub a balloon on a sweater, I should get a positive sweater and I should get a negative balloon. Okay, when we rubbed the balloon on the sweater, we got a positive wool, positive sweater, and negative rubber, negative balloon.